this tutorial, I want to show you how to combine Rat with Paraview to get the most out of your data analysis from your models that you create in Rat. In this tutorial, I want to specifically focus on like the plane calculation and mainly plane versus time for instance, this 4-layer CCT. So I quickly made 2 CCTs just by, adding, by right clicking here, you can add a coil and you can add a CCT. And one of the 2 that I added, I made the radius bigger for, so the radius is right here. So this one has a bigger radius, and I rotated it by 90 degrees. So that you have basically 2 dipole fields, one in this direction and the other one is rotated by 90 degrees. And now let's make a plane calculation. And in fact, we're going to make a plane calculation versus time. So that means we need to add a circuit. And in this circuit, we can, for one of them, we can make a sine wave with 1000 amps amplitude in one direction. So that's for the circuit for coil 1. So this one, let's just check what circuit ID. Yeah, so this inside has circuit ID 1. And then we add another circuit, powering circuit. We add it to the plane calculation. So always when I say you add something, I right click on the object and then I select from the list what I want to add. And here I want to add another powering circuit, also with a sine wave. Again, same amplitude of 1000 amps, but I want to shift it by 90 degrees. So that means that these 2 coils are charged and basically discharged with a sine wave, so an AC coil, both of them, but 90 degrees offset from each other. So they are not charged and discharged at the same time. If we now go back to the settings of the plane calculation over here, I'll make them slightly bigger. We can go to the VTK settings, and this is interesting for when you want to use Paraview. Paraview basically reads and stores data in VTK files. So first we select a directory. I already made a directory on my desktop called Paraview data. So that's the one I want to store my data in. And since I now should be able to calculate the magnetic field versus time, so basically at different time steps, I'm actually going to set a window from 0 to 0.5, because if I look at these circuits, oh no, actually to 1 second, because then I have a full wave, right? Because this wave, this AC current is going in a full wave in 1 second, so it's 1 hertz. And the number of times here that you can set is the number of points in time that you calculate for. Let's say 20, doesn't really matter. Of course, in your own analysis, you can make a much finer grid. Oh, and I see that actually we're plotting here in this direction, the plane, but I want to plot the plane like this. So in the Z direction, I make it square. So now we have a square plane, 50 points in one direction and 50 points in the other. And we're going to save all the data for 20 time steps between 0 and 1 second. I click calculate and write. And what happens then, it's basically not going to show me the results on the screen, but it will calculate the results and stores them directly in a VTK format. And actually it's done. It says finished here. I'm going to clear all this because now we're going to go to Paraview. When you want to get Paraview, it's free to download on the web. It's an open source tool. And basically, it's not just outside my screen here, but if you just want to believe me that for any application, there is also the file here. So I click on file and say open. And then I want to open the plane.pvd. So this is my Paraview data file, which I selected in red. And what it stores is it stores a few things, VTI files, but also PVD files. And if you do a time-dependent calculation, or if you if you want to show more than one time step, PVD is basically the main file that points to all the time steps. So that's the one we open. And initially in Paraview, when you open something, it's just basically the eye here is closed and you see nothing. Always you need to first click apply. As soon as you load something in the pipeline, like your data set, you click on apply. Now here in Paraview at the top, you see you can start at time 0 and you can basically move forward in time, and then you see the field rotate. And that's actually quite cool. So this is the field in the center plane of our two CCTs, right? So we have a rotating field. That's what we created by having two different AC circuits for the two dipoles. Now what we can do is go into the properties here, because this is how we can basically change our plot or whatever we see here in the render view. And one of the things I want to show is that all the data that will be calculated in the plane calculation, you're going to be able to plot that here. So by selecting here for the coloring, so the coloring means what is used to determine the color on your plot. I now select the flux density, so this would be the magnetic flux density. You can plot the magnitude, but also X, Y, and Z. That's kind of cool, because then you actually see this rotating dipole. For now, I'm just gonna plot the magnitude. And you cannot just plot slice, because there's you can plot it in points as well, but then it's kind of hard to see. I'm not sure if you even see that on your screen anymore. But one nice thing you can do is plot glyphs. And with glyphs in Paraview, we can actually make arrows, so you can also see the feed direction. Right now it doesn't look like much, but we're gonna make it better. So first we have the 3D glyph selected, and we want to plot the magnetic flux density. And then we scroll down here. Basically in this menu in Paraview, you can change settings for your plot. And we scroll down to the orientation. So we want to orient the glyphs, the arrows with direction, but with the magnetic flux. And we need to do something about scaling here. Oh, we need to select scaling. Right. This is much, much, much better. So what did I do? In glyph parameters, I check orient. So I want to orient it with direction of the field. And what field? Well, the flux density, because that's what we were plotting. And I need to scale, and now I'm just scaling basically the arrows. I normalize the arrows and I just make them bigger or smaller, but I can scale them also with the magnitude. Then I need to make it even more smaller. Oh, and I need to put flux density again, because that's kind of interesting, because then at the place where there's the highest flux density, the arrows are slightly larger. So that could be nice as well. Now, if you want to see this as a movie, I set the time here in the top again to 0, and I click on the repeat button, and then here basically there's a play button. And now you can actually see a movie of your rotating field that's created by these two dipoles that were modeled in the Rat GUI. So that's basically what I wanted to show for the plane calculation. I can pause it. If you want, you can export this as a movie. Now, I would make this look slightly nicer. So you can, by clicking on this color bar, you can move it around. We can actually edit by going back here into this properties menu. I'm going to make it bigger because right, this button allows me to go here and actually change here, for instance, the title. There's many settings. Most of them will actually just speak for themselves. Here I can change the font size, all that kind of stuff. You can change the length. If you want to have even more flexibility, always Paraview hides basically more settings under this cogwheel. So here as well, if you click the cogwheel or unclick the cogwheel, first let me do this. If I click it, I have even more control over my formatting. For instance, I don't want to have an automatic label format. I just want to have something that looks like numbers. Now I have this. Here as well, if I click on it, then I get a lot more settings than if I unclick it, basically. So that's nice to know. You can change the color also of your map. This is a different color map that you can select. Even the opacity, you can do some opacity mapping. That means that you can basically, here these dark colors, you can make them more opaque than the other ones, right? So you can make these very, very strong. Now, all this kind of editing, this orientation vector or orientation axis, I can turn off or on. That's all preference. I can move this even to the bottom. There's many things. I'm sure ChatGPT and Google will be able to help you with finding lots of settings here in Paraview. But what's nice is that if I click on File again, I can actually go to Export Animated Scene. Save Animation. Sorry about that. So if I save animation, I will just save it here. And I call it frame. Wait, let me create another file because that makes it easier. I will call this one animation. And inside here, I write frame, because what Paraview will do is it will actually save one file per frame. I don't want to overwrite the background color or have a transparent background mode. I just don't want to compress it. I want to have as much as possible. And here you can sort of set a frame rate, but I find that doesn't really do anything for me. And the frame windows, if I don't want to save all of them, I can also just store 10 frames. So Paraview is now for each frame writing a file. And if I need to open my folders then. I'm gonna put that here. So if I now go on animation, I have 10 frames and each frame will be the next part of the movie. Now you can put all these frames into your favorite movie editor and just save them as a GIF or something. That's basically what I wanted to show you for this tutorial. In the next tutorial, I will also use Paraview for a mesh calculation and also for the harmonics calculation, because there's some interesting things that we can do with that as well. So stay tuned for the next Rat and Paraview combined tutorials.